Okay, so for balancing chemical equations, so yesterday you basically all right. So yesterday you guys talked about coefficients, right? So coefficients are the big numbers that sit in the front. We use those in order to balance them because for something like this where I know that I want to make water, and this is where you can start writing. If I know I want to make water, I know that it involves hydrogen and it involves oxygen. But this is the only way that hydrogen and oxygen come. All right, they come in diatomic molecules. So I can't just put them together and make it H2O2 because that's not water. So that's why we use balancing. You have to put them in certain proportions in order to make at least one of these water molecules. Okay, and you and you want to make sure everything is used up, basically. Okay, so I'm going to show you my way, and I'm going to show you a visual way, and then we'll do it 2 more times. Okay, so my way is usually how you learn it. You probably did this back in middle school. You might not remember it, but you did it. So what you would do is you would list out who you've got. So for example, I have hydrogen and I have oxygen. Okay, so you have hydrogen and oxygen. Okay, then you would go ahead and start counting up how many of each one you have. So hydrogen's on this side, on the left-hand side, 2. How many on the right-hand side? 2. How many oxygens on the left-hand side? How many on the right-hand side? 1. Good. Okay. So this is the setup. You list out who you've got and you count up on both sides. Okay. So I'm just going to write the steps on the side if you want to write them. So. Okay, so the next thing we're going to do is we're going to start balancing using coefficients. So balance using coefficients. Okay, so looking here, I see that my oxygens are not balanced. Okay, so I know that this 1 can be multiplied by what in order to make it 2? It can be multiplied by 2. But I can't just do that down here, okay? I have to go and put a coefficient in front of my molecule. Once I do that, you have to recount. That is the most important step. So once I've done that, it didn't just affect my hydrogen. Now I have 4 hydrogens. I'm sorry, my oxygen. Now I have 4 hydrogens, and I have 2 oxygens. Okay, you guys see that? So how can we fix it back on the other side again? Who can we put a big 2 in front of? The H2, yeah, so we can put a big 2 here. Recount, okay? So now I'm going to have 4 hydrogens, and I'm balanced. So this is where my 2 to 1 to 2 ratio is coming from. So, just a reminder, these coefficients are coming, your mole ratio is coming from your coefficients. So that's what I'm talking about when I do that. People earlier today were asking, well, there's a 4 right here. Why doesn't that get put? We don't worry about how you got there. We worry about only the coefficients in the final thing. Okay? And this would be considered balanced. Okay? And this is my proof that it's balanced, basically. All right? Okay. So that's usually how you get taught how to balance, okay? But there's also the box method, okay? So now, just label off on the side, box method. We're going to use the same example so you can see it. Excuse me. So I have H2, I have some O2, H2O. Okay, so with the box method, what you're going to do is put molecules into boxes. Okay? So what this method is forcing you to do is it keeps things together. I don't have separate hydrogens. I have a molecule of 2 hydrogens. I have a molecule of 2 oxygens. I'm going to put a line down the center so I know that's my midpoint. That's the equal sign. And on this side, I have 2 hydrogens and 1 oxygen. Now, I like to stack my letters like this when I have a molecule with multiple elements, because it's easier on the eyes to count it, and it's easier to separate it out that way. If you wrote it all in one big line, it'd be a little overwhelming, but it's up to you and how your brain works, okay? All right. So now what we're going to do is add boxes. Notice I said add boxes and not letters, okay, to balance. Now we're going to add the box, and then you have to make the letters follow, but you can't just say, oh, I just needed one more O, so I'm just going to add an O right here. That's not how it works, okay? So I'm looking here. I have 2 hydrogens, so those are pretty good, but here I have 2 oxygens and 1. So in order to make this side look like the other side, I'm going to add another box that has a water molecule in it. That way now I have 2 oxygens, and I have 4 hydrogens, but 2 on this side. So what am I going to do? Add another box of hydrogens. Okay? Do you see how this is more for my visual people?
Yes.
Yes, thank you. Appreciate it. Okay, so your last step is to count the boxes. And that's your coefficient. So here I have 2 boxes, here I have 1 box, here I have 2 boxes. So you would end up writing it 2H2 plus O2 gives me 2H2O. And that's how you would have your answer. So I know that this one takes up a little more space, but you always have my whiteboards available to you. Okay, so you guys can use those even on the exam if you want to use the whiteboards. I'm going to be monitoring you because I don't want you like holding up the whiteboard to the people behind you. But just know that you have that option. Okay, so if the visual way is for you, then you have that. Okay, let me do 2 more examples and then I'm going to let you guys practice. Okay, so can I change slides? You guys all good? If you need to come back and see this after, you can come see it. So next example, let's do one from the worksheet yesterday. Lithium, throwing it into some water gives me a liquid called lithium hydroxide and some hydrogen gas. I'm sorry? So we're going to do the box method, and then we'll go back to the old method, okay? So box method for this one. First, we need to write everything in boxes, right? So let's put my lithium into his own box, because he's not paired up with anything. I have a water right here. So I'm going to go, just to make a point, I'm going to go OHH, just heads up. I recommend you write it that way, because I'm going to show you something in a second. Here's my line down the middle. This I have to write LiOH. I'm going to put it like that, and you'll see why in a second. And then I have HH. Okay, so once again, you can't change up anything. You can just add boxes of what already exists, all right? So looking at this, is it a little overwhelming to you to see that there's 1 hydrogen to worry about here and 2 to worry about here? You guys see that?
Yes.
So it's a little eh. And every once in a while you're going to have that. Oxygens and hydrogens like to get sprinkled around in all the different molecules, especially oxygens. Okay? And every once in a while you're going to have to deal with that. And you're going to just have to figure it out. Okay? And there's ways to get around that. As you come across them, you can ask me. But for this one, if you notice, water also has a hydroxide. Do you see that?
Yes.
So what I recommend is sometimes write water like this, because if you have a hydroxide involved, especially when you start doing acids and bases, it's going to be easier to see that than it is to see H2O for some reason. I promise. Okay, so draw the little parentheses around them in your box like this so that you see that you have a hydroxide and a hydrogen. Okay, so you have a hydrogen and a hydroxide, basically. Okay? All right, so now we're going to start making our pictures match. So I have one lithium on this side, one lithium on that side. Cool. Here I have one hydrogen. I have, two hydrogens. So what can I do to this side in order to make it have two hydrogens? Add another water. So again, we're going to do like that. Okay. Okay, so here now I have my two hydrogens, 1, 2. I have 2 hydroxides. I only have 1 hydroxide here. So what can I do? Add another box. And now I'm not done? Done? Not done? We need another lithium. We're going to add one more lithium. Now I'm done. Okay? Now I'm going to count up my boxes. I have a 2, 2, 2, 1. Okay? All right. So, so my little side note on this one, if you notice what we do, we treated our polyatomic as its own thing. So if you have a polyatomic, is on both sides, keep it together. Okay? Because if you, once you get to the ones where you have like phosphate, something like that, do you want to draw a box or write a thing out and know that you have like 4 oxygens and 1 phosphorus? No. It's easier to say I have 1 phosphate than it is to say this. Okay? So you'll see which ones to use it on, and like I said, everything is going to come with just experience, and you're just going to practice. Okay? All right, so let me show you one last way, the old way, which was listing out our characters. Okay, so here I would automatically say, oh, I see a hydroxide, so me, just being me, I would rewrite this as HOH so that I can see it. Now looking at this, I'm going to go list out my characters. I have lithium, I have hydrogen, I have hydroxide. I'm going to count up on both sides. So on my left-hand side, I have 1 lithium, I have 1 hydrogen, and 1 hydroxide. On the right-hand side, I have 1 lithium, 2 hydrogens, and 1 hydroxide. So I'm going to go mess with this first. So I'm going to fix that by putting a big 2 here, and now I'm going to recount. So now I have 2 hydrogens and 2 hydroxides. So I'm going to go to the other side, put a big 2 in front of this one. I'm going to recount. I have 2 lithiums, 2 hydroxides. So finally, I'm going to go back to the other side. I'm going to put a 2 in front of my lithium and show that I have 2 right there. Okay? And you end up with your 2, 2, 2, 1. Okay? Fun stuff. You got 7 practice problems to do. Okay? So you can either work on a whiteboard, or you may work in your journal, or you may work on a separate sheet of paper. The way it's going to work today